Find d dx of x times the hyperbolic inverse tangent of x plus ln of the square root of 1 minus x squared. Finding d dx is the same as saying differentiate or find the derivative. There are two terms, so we will use the sum rule, but with the first term, we would use the product rule, and with the product rule in the first term, we would need to know what the derivative of hyperbolic inverse tangent of x is. For the second term, we would need to use the chain rule because we have one function inside the square root and inside of ln function. The derivative of hyperbolic tangent inverse of x is 1 over 1 minus x squared. This is something that we derived. We can now proceed differentiating the first term using the product rule, and then we add derivative of ln after. The derivative of the first term using the product rule, the derivative of x is 1 times the second term. Leave the second term alone. Plus x times the derivative of the hyperbolic tangent inverse of x is 1 over 1 minus x squared. And we're done with the first term. For the second term, the derivative of ln is 1 over the argument of ln, which is the square root of 1 minus x squared. But then this is the inside function of ln. We need to multiply the derivative of this, but the derivative of the square root is 1 over 2 root 1 minus x squared. But then it has an inner function too, which is 1 minus x squared, so we would need to multiply the derivative of 1 minus x squared, which is 0 minus 2x. And then we clean this up. This is the hyperbolic inverse tangent of x plus x over 1 minus x squared minus 2x over 2, and the square root times the square root, we end up with 1 minus x squared. The 2 and the 2 canceled out, but we end up with x over 1 minus x squared minus x over 1 minus x squared, and so these two terms canceled out, and it gives us back the hyperbolic tangent inverse of x, and this is the answer.